Hello everyone, welcome to another exciting math problem involving algebra and number theory, which might be a bit challenging for beginners. Here is the problem. Suppose a, b and c are integers such that 1 over a plus bc plus 1 over b plus ac equals 1 over a plus b. Find all possible values of a, b, c. Before we dive into the solution, I encourage you to hit the pause button, grab your pen and paper and give it your best shot. When you're ready, feel free to share answers in the comment. Then let's explore the solution together. Let's get started. From the condition, we combine terms on the left hand side. Note that 1 over x plus 1 over y equals x plus y over xy. So in this case, the numerator is a plus b plus ac plus bc. Expand the denominator, we get ab plus a squared c plus b squared c plus abc squared. Note that ac plus bc can be written as c times a plus b. Now, a plus b is the common term in the numerator. By factorizing it, we obtain a plus b times 1 plus c. Hence, the equation transforms as follows. Let's continue here. Cross-multiplying, we obtain a plus b squared times 1 plus c on the left-hand side. Expanding the left-hand side, we get the following. Focus on these two terms highlighted in purple. Since a plus b squared equals a squared plus 2ab plus b squared, we observe some common terms in both left-hand sides and right-hand sides. By cancelling these common terms, we get a plus b squared plus 2abc equals ab plus abc squared. Thus, a plus b squared simplified as follows. Note that ab is a common term on the right-hand side. By factorizing it, we get ab times c squared minus 2c plus 1. Again, using the identity a plus b squared equals a squared plus 2ab plus b squared. We know that c squared minus 2c plus 1 is c minus 1 squared. So, c minus 1 squared equals a plus b squared over ab. Hence, c minus 1 equals the absolute value of a plus b over the square root of ab. Clearly, this expression is an integer. With this in mind, we may let ab equals k squared for some positive integer k. So the square root of ab is k. Since this expression is an integer, it means that the absolute value of a plus b is nk for some positive integer k. Now focus on these two relations, the sum and the product of a and b. Hence, we know that a and b are the roots of quadratic equation x squared minus pkx plus k squared equals 0. Now consider the discriminant, which is pk squared minus 4k squared. Factorizing it, we obtain p squared minus 4 times k squared. As a and b are integers, the discriminant must be a perfect square. So write p squared minus 4 equals q squared for some integer q. This means that p squared minus q squared equals 4. Factorizing the left-hand side gives p plus q times p minus q. For the right-hand side, 4 is 1 times 4 or 2 times 2. As p and q are integers and p plus q equals p minus q plus 2q. These imply that p plus q and p minus q are either both even or both odd. Hence, p plus q equals p minus q, which means that p equals 2 and q equals 0. Substituting p equals 2 into the previous quadratic equation, we get k squared minus 2kx plus k squared equals 0. Solving it, we obtain x equals k. So finally, we know that a must be equal to b. Using the relation we derived earlier, we find that c minus 1 squared equals 4. Hence, C is 3 or -1. Note that if A equals B and C equals -1, then A plus BC becomes 0. This implies that one term from the original equation is undefined. Hence, C equals -1 is not a valid solution. Now, checking for the other case, A equals B and C equals 3. The left-hand side of the equation is 1 over A plus BC plus 1 over B plus AC, which after calculation becomes 1 over 2A. For the right-hand side, it is 1 over A plus B, which is of course 1 over 2A if A equals B. Hence, the solution for ABC is A3 for each integer A. While we have successfully solved the problem, it's always beneficial to practice what you've just learned. Using a similar argument as shown just now, I believe you can solve the following question. Feel free to try it and share your answer in the comment. That concludes today's lesson. I hope you enjoyed the video and stay tuned for more exciting math challenge in the future. Until next time, take care and bye-bye.